Hello everyone. So in this video we're going to use this very nice diagram by Klein and Dutro to talk about screw axes. Screw axes are a way for us to talk about symmetry where we take a motif, in this case the authors of this book are going to use a comma, but instead of just having that comma rotate about an axis to create another comma, let's say we have an axis here, instead we're going to take that comma and move it. So you don't get anything here. We're going to rotate and then translate to get a new fellow over here. And we get a different kind of pattern. And what I'm starting to draw here is actually shown much better to the left in this diagram. So we have a regular twofold axis. So we have a comma here and one over here. And we can rotate them 180 degrees and we get the twofold rotational symmetries. There's nothing new there. Over here is the case I was trying to draw on the left. We can rotate 180 degrees, but instead of stopping there and having a motif in this position, we're going to rotate but then translate. And so that's why we use this letter T. We have some translation distance, and here the translation distance will be 1/2 of the distance to get from this fellow here over to its repeated motif over here. So if we call that the full distance T, we're rotating half the distance. And for twofold rotational axes, that's all that's really possible. You might think, well, why can't you just rotate 180 but then go down a quarter or a sixth of the way? Well, you could, but what you would be simply doing is redefining T. You can pause the video here and try drawing it on a separate sheet of paper. Try letting the motif only go down a quarter of the distance and let it repeat. You'll see you'll get this very same pattern that's drawn here. And if you simply define your T as the distance between this guy and then the next one who looks the same in that same position, then you'll simply have redefined distance T. So there's the possibility of a twofold with no translation, or we have a 2 sub 1. So what does the 2 sub 1 mean? It means that it tells us how far to translate. So we are going to write it this way. We'll take this subscript and make it a numerator, and take this and make it a denominator. And so we get the distance 1/2 T. So we could do that with any kind of subscript that we see written on a 2, 3, 4, 6-fold rotational axis. So let's look at the same similar kind of idea here with the threefold rotation with no translation. We just have 120 degree translation and we get that threefold symmetry here and there. But instead of having no translation, we can rotate something 120 degrees and let it drop 1/3 of the distance from here to here. And when we do, this first motif here ends up creating the second one right there. And we can have this fellow rotate 120 degrees, and it would generate that third one. It can rotate another 120 degrees, and it would contain that fourth one. So for the 3 sub 1, we are rotating 1/3 of the distance T from there to there. With the threefold axis, we can also rotate 2/3. And this is where the diagram gets a little bit tricky. If we take this guy and rotate it 120 degrees and then move down 2/3, then if this is our first motif, this is our second one. Notice we passed over this one over here. You might want to rewind the video before I wrote over this. So where did this guy come from? Well, he came from some other motif sitting up in this direction that's out of view. And if we take this guy and rotate it 120 degrees and then move it 2/3 the distance, it'll create a motif that is also below the field of view in terms of this diagram. If we take this one here and rotate it 120, the one I've drawn the question mark by, then we'll get this one here. So the numbering is not quite so straightforward. But in this case, it does give us a distinct set of motifs, a different pattern. And so the way we would distinguish that is with 3 sub 2. And that instruction kit is telling us to move 2/3 of the distance T after you rotate 120 degrees. We could play the same game here for 4-fold, simple 4-fold rotation with no translation, or 4-fold, which of course always means a 90-degree rotation. We'll move 90 and drop 1/4 the distance, and we would know that because that's a 4/1. Or we can move half the distance, because that would be 2/4, so we could rotate 90 and then move half the distance downwards. Or we can move, excuse me, this is the 3/4 case here. So we would rotate 90 degrees. If this is number 1, then 3/4 would be down here, and that would be number 2. This fellow here would be coming from out of the field of view. And then this is the half case. We rotate 90 degrees. If this is the first motif, then halfway down would give us this one. That would be the second motif in that system. And so we would distinguish these either as a 4 or a 4/1 or a 4/2 or a 4/3. So whether we have a 1, 2, or 3 subscript or no subscript at all, that's telling us about the translation distance, and that gives us unique patterns. And then we could play the same game with 6-fold rotation, where we have a few more options. We can have move 1/6 or 2/6, or which is essentially 1/3, 3/6, which is half, etc. So these are the screw axes, and the way we notate them is with this subscript notation. And they give us unique patterns. So we can have a 2, 3, 4, or 6-fold rotation. But then we can have screw axes where we can combine translation, and we get things like the 3/2 or the 3/1 or the 4/3 or the 4/1, etc.